Good morning. Good morning, grade 12s. It is a nice Saturday. Today is the 19th of September. Then we'll be doing technical mathematics. Then the topic that is going to be for today's lesson is calculus and integration. Those are two topics that we'll be focusing on for today's lesson. And now, before we can start our lesson, please, I just want to advise the technical mathematics learners that please go and try to get a examination guideline for technical mathematics. It's a very, very, very important document that you need to have because now it explains the important information that you need to know for each topic that is under technical mathematics. All right. And then let's get into today's business for these two topics and see what we are going to be doing. All right, under the content, we have the differential calculus and integration. And these two topics, they contribute 50 plus or minus 3 marks in paper 1. So it's very important. And now, under differential calculus integration, first you're going to get what? You're going to get the first principle, and rules of differentiation and average gradient. And then you move to cubic functions. And of course, the last one is integration. So those are three concepts that we are going to be discussing for today's lesson. Okay, now let's get into the first question. Now we're going to be dealing with the first principle. The first principle. Now let's get into the first principle and see. This is the formula for first principle, because this question, it will always be on the question paper, and it's very, very important question, and it will always tell you use the first principle. So if they say use the first principle, so this is the formula that you must be able to know, and you must be able to use it. All right, now let's get a question where you are going to be solving using the first principles. Now let's see how do we determine that. It says determine the derivative of f of x equals to 5x negative 12 by using the first principle. So it will always indicate that every time when you have to answer a question or when you have to derive, they will say use first principle. Now if you have to use the principle, so this is the formula that you're going to be using. Now let's see on how do we solve this question. How do we derive this one? By using the first principle. Now first you can see that we're having f of x, and then from the formula that formula for first principle, you can see up there we're having f of x. Now we can see that f of x equals to 5x minus 12. All right, and then because now we don't have f of x plus h, then we have to look for that. Now you can see that for x we are going to substitute with x plus h. X plus h. So where we see x, then we're going to substitute with that. You can see that there was x there instead of x, then we substitute with x plus h. Then from there you're going to simplify it, then it's going to give us 5x plus 5h minus 12. So this is going to be replace this f of x plus h. Now you then write the correct formula for that. And the second step, instead of writing f of x plus h, then we're going to substitute it with 5x plus 5h minus 12. All right. And then, of course, this one, f of x, already we've got it, which is 5x minus 12. Then please, you always put this one inside the bracket so that this sign can now change the signs of each term inside the bracket. Because now, if you don't put in the bracket, then it's good, the answer that you're going to get is not going to be correct. So always you must say minus and then you open the bracket so that The third step, we were going to be opening that bracket with that negative outside. And the other issue, please, my dear learners, every time when you write the formula for first principle, please continue with this lim h approaches 0. As you can see that I am continuing with it. Equal sign, I'm continuing with this lim h approaches 0, because you'll find that majority of learners, they like to omit or remove this lim h approaches 0 and then just continue with this, and which is not going to be correct. Now the third step, then we just open the bracket. You can see after opening the bracket, now this 5x is becoming now negative 5x, and then negative 12 becoming positive 12 now, right? And then you can see that this 5x and with this negative 5x, they are going to cancel each other, and then this one and this one, they're going to cancel each other. Then we are left with 5h over h. Then the answer is going to be 5, because now h divided with h there, it's 1, then we are left with 5. Now when you reach the final stage or the final step there, we don't put or include the lim h approaches 0, then you just write what f prime of x equals to 5. So that's how you should now end this question, right? And then you can see from this stage here where we have where we minus 5x and then also the 12. It will always be like that every time when you are solving first principle. These terms which are coming after this negative, they will always disappear. They are going to be minus all the time, all right? Because if they don't, they are not going to be cancelled or give us 0. Then somewhere you did a mistake. So make sure that you understand that you must open the brackets first, and then from there, the third step, you will then open those bracket or that bracket with negative 1. So that is the answer for that. And then let's proceed. We have another question. Calculate derivative of f of x equals to 5x minus x from first principle. First, to write f of x, you can see is now equals to 5 minus x. Now we are looking for x plus h. So where you see x, you just substitute with x plus h. Then you just open a bracket with this negative 1 outside. Then it's going to give us 5 minus x minus h. You write the correct formula. Then you substitute those values there. Then remember here, you can see the bracket. Minus of the formula, open the bracket. The third step, you open the bracket. Now you can see that this positive 5 is going to minus this 1, and then this negative x is going to minus this 1 all the time. Then we are left with negative h over h, and h divided with h is negative 1. So that is the answer for this question. All right, now we are done of using the first principle. Remember, we're deriving using the first principle, but now we are going to derive by using the rule, right? We're going to derive by using the rule. Let's see on how do we do that. All right, first you can see that there are notation that we are going to be dealing with. The first one is this one of f prime of x, or dy over dx, or the last one is dx. So these are notations that we are using when you are deriving. When you start deriving, then we're going to be using, it's either this one of f of x, f prime of x, or dy over dx. The last one is dx. Now remember the following points when deriving. First, remove any bracket. It means before we can start deriving, one of the rules says you should now remove the brackets. If you have a question that has brackets, then first deal with those brackets before you can start deriving. Number two, remove the divide line. It means when you have a fraction, and you have to derive, then first you have to deal with that fraction. We have to remove the fraction. And then the last one, the root sign, also the root sign. Then I believe we are going to have a questions where we have brackets and then where we have the division line on the root sign, so that you can be able to see on how do we deal with such questions before we can start deriving. Now the first question, for example, determine derivative of the following. F of x equals to into 4x minus 3 all over 2. You can see we've got brackets there. Now, before we can start deriving, my dear learners, let us deal with those brackets first. Now, the second step, because it's 2 there, then you're going to repeat this bracket twice. Thereafter, you're going to apply what you call a FOIL. You're going to multiply these 2 brackets, and then it's going to give us 16x squared minus 24x plus 9. Then you can still, on even this side, I'm still continuing with f of x, right? Because now what I'm going to be deriving is not yet ready, because I had to remove the brackets first. Hence, I'm continuing with this f of x. But when I start deriving, that's where I'm going to include what? f prime of x. Right now, you can see everything is fine on this third step. We don't have brackets, we don't have division sign, we don't have root signs, right? Now I can now start to say f prime of x. Now remember the rule on how do we derive. Remember, you're going to drop this exponent to this side and then minus with 1. The same applies with this one. You drop 1 this side, minus with 1. And then, of course, the 9 is the constant number, and we agreed that the constant number is always equals to 0. Then when you simplify this one, then it's going to give us 32x minus 24. Why minus 24? Because remember, this is x to the power 1 minus 1, and 1 minus 1 is 0. X to the power 0 is equals to 1. So this is the answer. This is the answer for that question. We have another one. Now this one, inside the bracket, you can see that we are having fractions. We are having division lines. You can see this one. Now before we can now start deriving, we have to deal with these fractions. And then now you can see that 2 over x squared, now it can be written as 2x to the power negative 1. And then this one of x cubed over 3, it can be written as 1 over 3x cubed. Now everything is fine. You can now start deriving, and you can see that I'm still continuing with the x because I'm not yet started with the derivative. And then from there, then I start deriving. Then I take this negative 2 and then drop it this side. You can see here this. Then you minus with 1 again. The same applies with this one. You drop this positive 3 this side. Then you minus with 1. Then you simplify it. Then it's going to give us negative 4 x to the power negative 3 plus x squared. That is the answer. The rules of differentiation, learn activity. Let's see what you're going to get. All right. Now the first question, you can see that it says determine the derivative of f of x equals to 4 to the power x plus this is cube root of 4, which is 1 over 4. You can see the root sign is there. You can see the root sign. Then you're going to be dealing with the root sign. Remember, earlier on we outlines on the rules that we need to remember before we can start deriving. That when you have a root sign, you have to remove it. Now let's try to remove that. You can see that we have to rewrite this root here S1 over 4, all right? S1 over 4, so that you can be able to derive. Now let's start deriving, and then you can just drop 4 this side, and then 4 minus 1 is 3. To drop this 1 over 4, and then 1 over 4 minus 1, it gives us negative what? 3 over 4. So that is the answer for that question. Number 2, you can see we're having fraction. Then we're going to simplify it. You can see on the numerator there, what we did, we take out a common factor as x, and then this is what you're going to be left with inside the bracket, which is x squared minus 1. And then because x squared minus 1 is different of 2 squares, then just do different of 2 squares. Then you can see this bracket and this one, they are going to cancel each other. Then we'll be left with this one. And you can see that I'm still continuing with y, because I cannot start with the y over the x. I only start writing the y over the x when I start deriving. But because I'm still fixing, still removing the fractions, still removing the brackets, then I have to continue with y. Then you're going to open bracket with this x outside, then we're having y equals to x squared minus 1. Then now you start writing the y over the x, and then this is going to give us 2x minus 1. So that is the answer. All right, we are done with derivative of using the rule. Remember, we have started with the first principle. We went to differentiate using the rule. We are now dealing with the average gradient. Average gradient. How do we calculate the average gradient? All right, the first question says, find the average gradient of the graph this between x equals to -1 and x equals to 3. Now remember, when we're in grade 11 and then they ask us to calculate the gradient, we say gradient equals to changing y over changing x, right? Then we must have the values of x, we must have the values of y, so that you can be able to calculate the gradient. Now, even on this one, we still going to use the same formula of calculating the gradient. All right. Now, but the problem on this one is that we are now having only x values from those 2 points. We're having x values, right? Now, how are we going to obtain the y corresponding values? It's simple, it's easy. Since we've got the equation of the graph, which is f of x equals to x squared minus 4, then we'll start determining the y values first, and then we're going to take the first x value, substitute to the given equation, and then it's going to give us what? It's going to give us -3. Then, therefore, that is the first point. That is the first point, which is -1 is to -3. Then you substitute 3 to the equation, then it's going to give us 5. That is going to be the second point. Now, since we have got 2 points, then it's going to be easy for us to calculate the average gradient. You just write the correct formula for average gradient, and then you substitute the values, then you just press your calculator, then it's going to give us +2. So that's how we should now determine the average gradient. Let's have another example. Given f of x equals to x cubed minus 6x, and determine the average gradient between the point x equals to 1 and x equals to 4. Now, first, we are now looking for y values now. We are looking for y values. Then we're going to substitute the first x value there, which is 1 on the given equation. Then it's going to give us -5. Then it's going to give us first point. And then we substitute the value of x, which is equals to 4, to the given equation. It's going to give us -8. Then we have the second point. Therefore, we can now be able to calculate the gradient. You write the correct formula for the gradient, and then you substitute. Now, the other issue on this one is that I want to make learners aware is that you'll find learners not writing or getting correct gradient, whereas they are having the correct point. Now, the problem is that now you'll find that we'll start with YA here and then say minus YB, but on the numerator there, instead of starting with XA, then the learner will start with XB, right? Here is supposed to be X, not Y. Let me just fix this one. This is not Y, this is X. This is X, my dear learners. This is not Y. Just the typing error there. It's supposed to be XB, right? It's XB. But now I was trying to explain this issue of if you start with YA, you must also start with XA here. If you have started with YB, you must start with XB. Then you're going to get the correct gradient. Now, the third step, you substitute the values, and then you have the answer as -1. That is the correct answer. That is the correct answer. All right, finding the equation of a tangent to the graph function. Now remember, we have done the first principle. We have done the differentiation using the rule, and then we have also determined the average gradient, where we are having two x values and then one equation. And then from there, for you to be able to calculate the average gradient, remember we need 2 points. Now, because we don't have y values or y corresponding values, now we had to take those x values to substitute to the given equation so that we can now obtain what? The y values. Now we are into finding the equation of a tangent to a graph of function. They are saying the gradient of a tangent is equals to the gradient of a curve at the point of contact. Thus, the derivative of the graph at the point of contact is equals to the gradient of a tangent. The gradient of a tangent meaning is equals to the derivative of a given curve or a graph at the point of contact. All right. And you can see from here it says the equation of a straight line, which is this one. Remember, when we talk about tangent, we actually refer it to a straight line because now tangent is a straight line graph. And remember, the standard equation for straight line graph is y equals to mx plus c. And then the gradient is equals to the derivative of a curve. So this is the summary for this statement here. This is the summary for that statement. Meaning when you have a gradient from a tangent and then derivative of a curve, those two are equal according to this statement, right? Now let's get example 1 that says determine the equation of the tangent to f of x equals to x squared plus 4x plus 3 at the point of 2:15. We are now looking for the equation of a tangent. Now remember, I have said that the tangent is a straight line, and for you to be able now to get the equation of a straight line, we only need two things. One, we need a point. Two, we need a gradient. Now you can see from the question that already we are having what? We are having a point there. You can see we're having a point. So the issue around point is not a problem, but now the problem is what? Is the gradient. How are we going to obtain the gradient? Let's see on how do we obtain. You can see that is the graph, and that is the tangent, and the graph of parabola and then the point of contact, which is 2 is to 5, 2 is to 15. To find the tangent, you need gradient and a point. Already we've got a point. Now how do we obtain the gradient? First, for you to be able to determine the gradient, we are going to derive the given curve or the given equation, which is f of x equals to x squared plus 4x plus 3. You first do the derivative, and the first step we are going to equate this. Actually, we are going to do what? Where you see x, then we're going to substitute with the value of x from the point, which is 2, and then the answer is going to be 8. Now, this 8 is the gradient, right? Because it's very clear even from this notes there, they are saying the gradient of a tangent is equals to the derivative of a curve. Now we did the derivative there. You can see we did the derivative. Then thereafter we then substitute a value of x. Then the answer that we're having here is going to be the gradient. And in this one we're having now a gradient. We're having a point. Then you write the standard equation for a straight line graph. And then from there you then substitute the values, y1 which is 15, and then x1 which is 2, and then from there you simplify it, you transport this negative 15 this side, then it's going to be positive 15. Then you're going to open this 8 put this bracket with this 8 outside. It's going to give us 8x minus 16, and then the equation of the tangent is y equals to 8x minus 1. Now let's get another question. Find the point of contact. Find the point of contact. Find the point of contact. Now remember a previous example, we were determining the equation of a tangent, and then we're having a point. We're also having an equation of a curve. Now let's come to this question and then try to understand what we have to answer here. Determine the point of contact between the tangent with the gradient of 8 and the curve, which is this one. Now you can see on this one, we are now not having what? We are not having that point of contact where this graph and the tangent, they meet. We don't have that point. Now we have to determine that point. Now the question is, how are we going to determine that point? All right, how are we going to determine? Because now we are from this given scenario, we're having a gradient, we're also having a curve. Now this is how we're going to determine a point. First, we are going to derive the given curve, which is 4x squared minus 1. Then when you derive, it's going to give us 8x. Now remember, we said that the derivative of a curve is equals to the gradient of a tangent, and then you can see that we're having the gradient of a tangent which is equals to 8. Therefore, we're going to equate the two. 8 equals to the derivative of this curve, which is 8x. And then from there, you solve the value of x, and then the value of x equals to 1. So that is the value of x for that point that we are in need of. So that the value of x from that point. And then from there, if you now have to calculate the y corresponding value, then you are going to take this value of x, you substitute original equation so that you can get the y value there. Is what we did, and then the y value is going to equals to 3. So the point is 1 is to 3. So that is the point. Find the equation of a tangent. Yeah, we are now having another question where we have to determine the equation of a tangent. determine the equation of a tangent of this at a point of 4:2. Now first we need a gradient because already we've got a point. Now for you to be able to get a gradient, we have to derive the given function. Now remember the rules. Remember the rules. When you have a fraction like this one, we need to rewrite it so that you can be able to derive. Then if 8 over x, then it's going to be 8x to the power -1. You can now start writing dy over dx. Then it's going to be -8x to the power -2. Now, because now we've got the value of x from this point, then we're going to substitute with that +4. The answer is going to be -1/2. So that is the gradient. That is the gradient. Then now we can be able to calculate the equation of a tangent. And then the second step, we just substitute the point there as well as the gradient. Then you just open the bracket with this -1, 1/2. Then it's going to give us -1/2x. It gives us +2. Then of course this -2 you're going to transpose to the right hand side. Then it's going to be positive there. And then you just add. Then the equation of the tangent is y equals to -1/2x plus 4. So that's how we should determine the equation of a tangent. Find the point of contact. Find the point of contact. Let's go back to that question on how do we find the point of contact. Determine the point of contact of the tangent to the curve is -4, and the curve is this one. Now first you take the equation of the curve, then you derive it. After deriving it, we said the derivative of the curve or a graph is equals to the gradient of a tangent. And we're having the gradient of a tangent as -4. Then we are going to equate the two, and thereafter we then solve the value of x. The value of x in this case is going to give us -3, meaning from the point that we are looking for, we are now having the x value there. What we don't have is the y value. Now for you to get the y value, you are going to substitute this one to the original, not the one that you derived, but to the original, so that you can get the y value. Then you substitute -3, then it's going to give us what? It's going to give us +2. So the point is therefore -3:2. So that's how you should determine the point of contact, right? Where there is the tangent and the curve meet. I think we are done with determining the equation of a tangent as well as determining the point of contact, right? So please go and revise such things so that you can now be ready for this coming trial exam as well as the final examination. And then the last point that I want to make, remember we have started with the first principle, and then we went to the differential what we're deriving using the rules, right? So please, every time when you come across such questions, you must be aware, when do we use first principle, when do we use what? The rule. All right, it's very important. Now let us deal with the cubic function now. The cubic function. The first question say we are given this cubic function, which is f of x equals to x cubed plus 4x squared plus x minus 6. That is the given cubic function. Now the first question says show that x plus 1 is not a factor. Show that x plus 1 is not a factor of this. And then let's see on how do we do that. Remember, if that is not a factor, meaning when we have to substitute the value of x to the given function or equation, that is not going to give us 0. First, we have to now to solve for x on this one. Then we can see the x is -1. Then let us substitute the -1 to the given function. The answer is -4, and therefore x plus 1 is not a factor because the remainder is -4. It will only be a factor, x plus 1. It will only be a factor when you substitute that value to the given equation, and then the remainder becomes 0. Then that will be that is going to be a factor. But the fact that is not equals to 0 then is equals to 4, meaning that x plus 1 is not a factor. All right. And 2, determine the x-intercept. Let us determine the x-intercept. Let us factorize this polynomial. Now remember, first we say if you want x values there, you let y to be 0, then we have to make this 0 equals to x cubed plus 4 x squared plus x minus 6. Now after this, then first we're going to be looking at what? At the factors of 6, meaning values that we're going to use or substitute on this, and then they give us the remainder as 0. We want a value that when you substitute where you see x and then you press calculator, the remainder must give us 0. We are looking for that value. Now when you substitute 1, to this, it's going to give us 0. You can test it. It's going to give us 0, and that one is this one. You can see the one that we have substituted is this one. Then now we are going to be using the synthetic method to factorize this polynomial. All right. Then first, what we did, we looked for a number that we substitute where we see x, then it's going to give us answer at 0, which is the remainder. That value is +1. Thereafter, you draw this line like the way I did here, and then you're going to take the coefficient of x cubed, which is 1, coefficient of x squared, which is 4, you can see as 4, coefficient of this x is 1, and of course the last term, which is negative 6. All right. And therefore, what you're going to do, you're going to now drop this one here. You're going to drop this one, the first one, you have to drop the 1. And then from there, you're going to say 1 multiplied by 1 is 1. 1 plus 4 is 5. It's supposed to give you 5 here. All right. And then 5 times 1 is 5. 5 plus 1 is 6. You are having 6. 6 times 1 is 6. 6 plus minus 6 is equals to 0. Then that is always give you 0. The value that is coming on this side, it will always give you 0. If it does not give you 0, then somewhere you committed a mistake. You committed a mistake somewhere. You need to recheck your calculations correctly. All right, let's see. And now we're getting 1, 5, 6, and 0. That's what we got. Let me just remove mine. And then now after this, we can see that 1 is the value of A, B is 5 is the value of B, and then 6 the value of C. Then now we're going to write 0 equals to, remember we are solving for x, right? The x-intercept. That hence you see a 0 on the left hand side, because now when you calculate the x-intercept, you make y equals to 0 there. And then this x minus 1, how do we obtain this x minus 1. You remember earlier on, sorry, let me just remove this one. Let me remove this in this one. You remember I said the value that we have substituted with here is going to give us 0, and that the value is 1. Meaning when x equals to 1, then we're having a remainder as 0. Therefore, if you take this one to take it back to the left hand side, it's going to be negative 1. And then this is a factor. That this x minus 1 is a factor. And then that's where you have to write it. Here is a factor. And then now we have ax squared plus bx plus c. Now we have determined the value of a, we have also determined the value of b, and the last, which is the value of c. Then the second step, now you substitute the values there, and then you can see this what this say the quadratic. Then we are going to factorize that quadratic. Then it's going to give us x minus 1, x plus 2, and x plus 3. And then the values of x is x minus x equals to 1, or x equals to minus 2, and the last one x equals to negative 3. Those are x-intercepts. The question is still continue. Given f of x equals to x cubed plus 4x squared plus x minus 6. Determine the y-intercept. Remember, we've determined the x-intercept. Now we are in need of y-intercept. Y-intercept, you let x to be 0. And then where you see x, you substitute 0, and the answer is negative 6. So the y-intercept is equals to negative 6. Find the coordinates of the turning points. Remember, a cubic has 2 turning points. And now let's go and calculate that. Now first we have to do the derivative of the original equation. Then the derivative is going to give us 3x squared plus 8x plus 1. Thereafter, you're going to equate it to 0 so that you can be able to solve the x values there. Then you're going to factorize this one. Now, because you can see we don't have factors, then we can now use the quadratic formula to calculate the value of x. And then just have the correct substitution. And then the values of x is negative 0,13, and the other one is negative 2,554. And therefore, because now we are having the values of x for these 2 turning points, we want the y corresponding values. Then we're going to take this one, the first x value there, substitute to original equation before we can start deriving. And then the same applies with negative 2, negative 2,54. Then you're going to substitute to get the y corresponding value. And then for this one, the y corresponding value is negative 6,04. And then for negative 2,54, it's going to give us 0,9. Those are y corresponding values for those x. And then now we're having the 2 points, the turning points. The first turning point is negative 0,13 is to negative 6,06. And the second turning point is negative 2,54 and is to 0,9. Those are the turning points, the coordinates of a turning point. Sketch the graph of f, indicate all the intercept and the translational point. Now remember, we have determined the x-intercept, we have determined the y-intercept, as well as the turning points. We can now be able to plot the cubic function. Now, this is the answer. You can see the cubic function. Here's the answer for the cubic function. Here's the turning point that we have and the other turning point that we have. And remember, and this is negative 3, negative 2, and positive 1. Those were x-intercepts. And then y-intercept, it was negative 6, you can see. And then another turning point is down there. So that is the answer for sketching or the graph of f. So that is the graph of f. All right, now we are done under cubic function. We are now into integration. I think this is going to be the last part for this lesson. It's going to be the last part for this lesson. Now let's continue. Let's say after complete the integration, you must be able to apply the standard form of integrals as the converse of differentiation. Apply the rules for integration for the functions, and then apply the integration to determine the magnitude of an area including by a curve and the x-axis, or a curve, the x-axis, and the coordinates where x equals to a and then x equals to b, where a and b are element of integer. So that is what we are going to be dealing with under integration. It's a very important topic that you need to understand. It is quite simple. You just have to understand the procedure, understand all the procedure that we have to know and then follow, so that come a final exam, you know on how to deal with integration. And then the other thing is that what I've realized is that learners, they confuse integration with derivative differentiation. Where they have to derive, they apply the integration rules. Where they have to integrate, they apply the derivative or differentiation rule. So you must be aware of that. Let's get an example or under integration. The first question said integrate or determine the full integration or integrals. Integral of -6 over x dx. Let's see on how do we do that. The answer is going to be -6 ln x. It's only when x is what is denominator and that x is the exponent of that x is +1. So then it's going to give us -6 ln x plus c. And then again, boys and girls, please don't forget under integral or integration, we always add plus c. We always add plus c because they sometimes give you a mark just to add this positive c. You will get a mark for that. So please don't forget to write this c when we are dealing with integrals. The second question is this one, and then let's see on how do we do that. Now the same applies on this one of integral. Before we can start integrate, to integrate, we have to now remove the first bracket there. We have to deal with this bracket first, and then we can see we multiply these two brackets because these two brackets, because of these two exponent 2, then it's going to give us x squared minus 2 2x plus 1 dx. Now the rule of integral is integration is exponent you add with 1, and then what we did here, then we want to divide with it, and then this is going to give us x cubed over 3 minus 2x squared over 2 plus x plus c. Don't forget c. So that is the answer for that question. And then I think we are done on this one. Now we can have another example under integration. Determine the integral of this. Now the solution. The first step, we need to rewrite this fraction, and then we're going to say 2x power 8 over x cubed plus x power 5 over x cubed minus 13x squared over x cubed dx. Then you can see that I'm continue with this integral sign, but by the time I start integrating, that's where I'm going to now to remove that sign and now replace it with equal sign. You can see now I'm starting integrating. This one is going to give us 2x to the power 6 over 4, over 6. Remember, you add plus 1. It's not the same with that one of differentiation where we minus with 1. In this case, we are going to add with 1. And then this what we are having there. And then, of course, this one is going to give us 13 ln x plus c. So this is correct, this is correct, this is correct, and plus c is correct. So that's how you should go about this one. We still have another example under integration. Evaluate the following integrals. The integral of 3 over x dx. And let's see on how do we solve this one. Now, every time when the denominator is x, then it's going to introduce ln. Then the answer is going to be 3 ln x plus c. And the second one, say x squared plus pi dx. And the answer is going to give us what? X to the power 3 over 3 plus pi x plus c, right? And the third one, and then t squared plus t plus x dx. Then it's going to give us t to the power 3 over 3 plus t squared over 2 plus xt plus c. Because remember, we're integrating with respect to t. Then hence you see t way on this x. And determine the magnitude of an area. Now in this one, we have to use the integration to determine the size or the area. Then we're going to be using the integral. Now we have what? They're saying apply the integration to determine the magnitude of an area where we are going to apply the definite integral. We're going to use the indefinite. Remember, we're dealing with indefinite integral. Indefinite integral. Now, in this case, we're going to use indefinite integral to calculate the area under the curve. And define the integral as what? As this. Now, every time when you come across the integral sign that is having this a and b, you must know that we are dealing with a defined integral. Definite integral, definite integral, where b is the upper limit, and then a is the lower limit. You can see from the picture there, where is the upper limit and where is the lower limit. This value, the value that is 30 is the lower limit, and of course this one is going to be the upper limit. So that's what we're going to be using to calculate the area under the curve. You can see this area here. If you're in need of this area, then that's what we're going to be using. Let's get example 1. The sketch below represents the bounding area. The sketch below represents the bounded area of the curve of the function given by f of fx equals to x squared plus 3. Determine the shaded area bounded by the curve and the x-axis between the point where x equals to -2 and x equals to 1. Now we need to determine the area of this shaded part, this part there. We need to determine the area of that part. Now first, we need to write the integral sign that is having the lower upper limit and the lower limit. And then, of course, this -2 is going to be the lower limit, and then 1 is going to be the upper limit. The second step, what you do, you're going to integrate x squared plus 3, then it's going to give us x cubed over 3 plus 3x. Then those upper and the lower limits, then you're going to put them on this side. And then, of course, up there is the upper limit, and then down there is the lower limit. Thereafter, you're going to write the first bracket where you are going to be substituting the upper limit, which is 1. Where you see x, you just substitute 1, minus the second bracket where you're going to be substituting the lower limit, which is -2. Then you just press your calculator, then the answer is going to be 12 units squared. Remember, we are calculating the area. So hence, you can see it say units squared because we are calculating the area. So that's how you must calculate the area under the curve. The graph of f defined by f of x equals to negative x cubed plus 6x squared is drawn below. Determine the area of the shaded region of the graph of f bounded by the graph and the x-axis between x equals to 1 and x equals to 4. So this is the area, the shaded one. Then we're going to be calculating that area there. And then 1 is going to be the lower limit, and then 4 is, of course, is the upper limit. Then you write the integral sign. Then you do the integral of this x cubed and this 6x squared. Then it's going to give us minus x to the power 4 over 4 plus 6x to the power 3 over 3. Then you put your upper limit there, and then the lower limit there. Then the third step, you then substitute with the upper limit first, where you see x, you can see there's 4 there and 4 there. Then minus, you then substitute the lower limit where you see x. Then from there, you just press your calculator, you put everything on your calculator, it's going to give you 62.25 units squared. So that's the volume of that the area of that curve. Area of curve below under the axis. Now remember, we've been calculating the area which is above the x-axis. We've been calculating the shaded part or the shaded area that is above the x-axis. Now, what is going to happen if this area that we are calculating is now below or under the x-axis? What is going to happen? Now, to calculate the area below the x-axis, then it's going to be area equals to this. Now, what we are going to be adding is just this negative there. We start with negative, the integral sign that is having the lower and the upper limit. All right. Example, the sketch below is defined by f of x equals to 2 minus x. Determine the magnitude of the area if the ordinates. The ordinates are x equals to 2, x equals to 4. First, you write negative because now the area that we are calculating is below x-axis. Then hence you see negative there, and the lower limit is 2, the upper limit is 4. Then you do the integral of 2 minus x, which is 2x minus x squared over 2. Then of course you put your upper limit there, the lower limit. Then you just open the bracket first, and then you open bracket, and then from there you're going to substitute first with the upper limit, which is 4, where you see x, you substitute before, minus, and then where you see x, you substitute with the lower limit, which is equals to 2, then just put 2 there. Then you press calculator, then the answer is going to be 2 units squared. So that is the value of what? Area. The graph defined by f of x equals to x cubed minus 3x squared minus x plus 3 is drawn below. You can see that is the graph. It's a cubic function. It's a cubic graph. Can you see that? It's a cubic graph. And the x-intercept of the graph are x equals to -1. You can see -1, x equals to +1, x equals to +3. Now the first question, determine the area of the strip region of the graph of f bounded by the graph and the x-axis, where x equals to -1 and x equals to 3, meaning we need this area here. We have to calculate that area. We also have to calculate this area there. So this is area above the x-axis. This is the area below the x-axis. Now first we have to start with the area above the x-axis. Then you just write the normal integration without negative, because now we are dealing with the area above the x-axis. Then you're going to do the integral of this. Then it's going to give us x to the power 4 over 4 minus 3 x to the power 3 over 3 minus x squared over 2 plus 3x. Then you put your upper limit, the lower limit. The third step, you're going to start substituting with the upper limit where you see x, and then the second bracket, then you're going to be substituting the lower limit, which is -1. Then you press calculator, then the answer is going to be 4 units squared. That is the area for the first region, which is this one. And then now let us go to the second region under the curve or under the x-axis. Then remember, you write negative, because now we are calculating area under or below the x-axis. So hence is negative first. The integral of that, already you have determined it, we know. Then you put you write your upper limit, the lower limit down there. And then the third step, you start substituting with what? With the upper limit where you see x, you substitute with +3. And then the second bracket, then you will be substituting with +1 where you see x. Then you put bracket and see for this negative, because whatever that you're going to be getting inside here, then it's going to be multiplied by this negative out there. Then the answer is +4 units squared. So that is the area for this region there. And then because we want the area of the whole or both strip region, then hence we said 4 plus 4, then it's going to give us 8 units, meaning the area of both region, both region, then it's going to be equals to 8 units squared. All right. All right. Thank you very much for being with me on this very interesting lesson. I hope we are going to be enjoying this lesson. And then this is the last message for you, boys and girls. That says, study like there's no tomorrow, because if you keep putting off your studies for tomorrow, then probably you'll be too late. Please avoid this thing of postponing when you have to study. Make sure that every time you use that time wisely, and then open your books and study thoroughly. Prepare yourself for this coming trial exam. Prepare yourself for this coming final examination. I know that it was a very hard year for us because of this pandemic, which is the COVID-19. But I believe that we are going to cope when it comes to the trial examination as well as the final examination. We just have to take this opportunity and then try to practice, try to study, so that we prepare ourselves very well for the incoming final examination. All right. And then if we have any question with regard to this lesson that we've been doing, you can send me an email. Any question that we want to understand under technical mathematics. Have a nice day. Thank you very much.